In this lesson, I'm going to demonstrate how to graph a linear equation from standard form. The learning target states, I can graph a linear equation written in standard form. The language target says, I know I can do this when, given a linear equation in standard form, I let x equal 0 and solve the equation for y. Then, let y equal 0 and solve the equation for x. Use that information to plot each intercept on the coordinate plane. And then finally, connect the two intercepts with a single straight line and draw arrows on the ends. If you have not yet watched the lesson video on how to complete these first two steps, please do so before watching the remainder of this video. Looking at the directions in the notes, it says to use intercepts to graph each linear equation. Beneath each equation, you will note that I have specified where I'm going to use space to solve for the x-intercept and where I'm going to use space to solve for the y-intercept. Instead of writing out the word intercept all the way, it is perfectly acceptable to use int with a period as an abbreviation. Instead of writing each step out very directly as we did in the previous lesson, I'm going to permit you to now use a couple of shortcuts. If I'm thinking about solving for the x-intercept, I know that I need to plug in a 0 for y, which would make the y part in my equation disappear. Since that is equivalent to 0, I no longer have a y term. So in order to solve for the x-intercept, I simply need to write an equation that contains only the variable x. So looking at this equation of negative 8x plus 12y equals 24, in order to solve for the x-intercept, I need to write an equation without y in it. Similarly, in order to solve for the y-intercept, I know that I need to plug in a 0 for x, which would make the term with x disappear, and all that would remain is y. Therefore, I need to write an equation with only a y term in it, which in this case would be 12y equals 24. It is perfectly acceptable for your first step to look like this when solving for the intercepts. Just make sure you include any signs that need to be included with the appropriate equation. Looking at this x-intercept equation, I know that I need to solve by dividing the negative 8 away from the x, because what's happening is multiplication, and the inverse of multiplication is division. On the left-hand side, I bring down the x, I bring down the equal sign, and on the right-hand side, I calculate 24 divided by negative 8 to be negative 3. Finally, just for the sake of practice, please also write the point, or that intercept, as an ordered pair, negative 3, 0, with parentheses. Looking at the y-intercept equation, similarly, I know that I need to divide in order to solve. So I'm going to divide both sides by 12 so that the y is now by itself. And on the right-hand side, 24 divided by 12 is 2. Once again, please practice writing the intercept as an ordered pair, 0, 2. Now let's practice actually graphing these intercepts and connecting them to form a line. When I'm looking at graphing either intercept, it will likely be easier for you if you simply take a look at this part here, noting that that says that x is equal to negative 3 and y is equal to positive 2. Remember that the x-axis is your horizontal or left to right axes. So if I want to find where x equals negative 3, I start at the origin, I'm going to look to the left in the negative direction, and I note that x equals negative 3 here. So I'm going to plot a point at x equals negative 3. Similarly, I am now going to plot where y equals 2. Y is the axis that is vertical, going up and down. Since I'm looking for 2, I'm going to go up in the positive direction, and I'm going to make a point there on the y-axis at 2, since y is equal to 2. Now that I have my two intercepts graph, I'm going to connect them with a straight line, and then I'm going to add arrows on the ends to indicate that this line continues forever and ever in both directions. Let's graph the next equation written in standard form. It states that 2x add y is equal to 4. In order to find the x-intercept, I need to make the y term go away by putting in a 0 for y. And what remains is 2x is equal to 4. Another way to think about it is I need to know what x equals, so I will write an equation with only x in it. Next, I want to know what y equals, so I will write an equation with only y in it, or I'll just cross off or cover up the x part, or I'll think about the fact that I'm plugging in a 0 for x, which makes the x term disappear. What remains is y is equal to 4. Looking at the x-intercept equation, this should be relatively familiar. I must solve by dividing, because the inverse of divide is multiplication. I drop the x, I drop the equal sign, and on the right-hand side I perform the math. That tells me 4 divided by 2 is equal to 2. So this intercept is 2, 0. Looking at this other equation, I actually don't need to solve it, because the y is already by itself, so I know that y is equal to 4. When I write that intercept as an ordered pair, it is 0, 4. So let's go ahead and graph those two intercepts. The first one tells me that x is equal to 2, so I'm going to plot a point at positive 2 on the x-axis. The second equation tells me that y is equal to 4, so I'm going to plot a point on the y-axis at positive 4. Lastly, once we've plotted the intercepts, we may connect them with a straight line and draw arrows on the ends. Notice on the next page that the directions remain the same. We must use the intercepts to graph each linear equation. This equation says that negative x add 3y is equal to negative 3. And in order to find the x-intercept, I must write an equation with only x in it, which would look like this. Once again, be careful with the signs. Next, to find the y-intercept, I want to plug in a 0 for x to make the x term go away, so that I can write an equation with only y in it, and it would be 3y is equal to negative 3. Looking at the first equation, we once again must solve by division, because that is multiplication that is occurring between the negative 1 and the x. Negative 3 divided by negative 1 is a positive 3. And then again, I want you to continue getting practice with writing the intercept as an ordered pair. Looking at the equation with y in it, I must divide that 3 away because multiplication is happening there. Y remains on the right-hand side, on the left-hand side, and on the right-hand side, negative 3 over 3 is negative 1. Lastly, practice writing it as an ordered pair, 0, negative 1. Now, it's time to plot each point on the coordinate plane. I'm going to plot a point at a positive 3 in the x direction for the x-intercept, and a negative 1 in the y direction for the y-intercept. Once the 2 points are plotted, it is appropriate to draw a single straight line and add arrows on the ends. Let's take a look at one more equation. Once again, I want to write an equation with only x in it in order to find the x-intercept, which means I am putting in a 0 for y. What remains is negative 2x is equal to negative 8. Similarly, if I want to find the y-intercept, I'm going to plug in a 0 for x, and I know that the y part of my equation must stay. What remains is negative 4y is equal to negative 8. Similar to the previous problems, we are once again going to solve each equation by division because what's happening is multiplication. In the first set, x is equal to positive 4. In the second set, similarly, y is equal to positive 2. So now I'm going to plot those points on the coordinate plane provided to the right. X is equal to 4 right here, so I'm going to plot a point on the x-axis. Y is equal to 2 would be straight up from the origin. Once I have the 2 points plotted, I may connect them with a straight line, a single straight line, and add arrows on the ends. And that is how you can use intercepts to graph linear equations written in standard form.